All right, now that we've reviewed what makes a function, we're going to review function notation and evaluating functions. So, little math history link here about Euler. You'll learn a little bit more about Euler when you get to calculus. He's got a method for solving things that is quite fantastic. Very smart guy. All right, I can write equations in function notation. All that means is we understand the idea that instead of writing y, I can write that as f of x. And then we need to remember which one is our dependent variable, which one's our independent variable. Remember your y value, which is your output. It depends on whatever you put into your machine. So your x value is your independent, because it doesn't depend on anything. You put in whatever x you want to. The y value that comes out depends on what you put in for x. So dependent variable is y, it depends on the x value. Independent variable is x. And then we can write y as f of x to make it function notation. Those two things are the same. All right, and now we can find function values. So hopefully you remember from Algebra 2, to evaluate f of 12, that just means plug in 12 everywhere you see x in your function. So for 4a, f of 12 would be 2 times 12 plus 3 over 12 squared minus 2 times 12. Oops, missed a one there. Minus 2, let's just get this right, times 12 plus 1. 2 times 12 would be 24 plus 3. 12 squared is 144 minus 2 times 12, so minus 24 plus 1. And then 24 plus 3 is 27. 144 minus 24 would be 120 plus 1, so it's over 121. All right, f of 6x, a little bit more challenging. Now every time I see x, I'm going to put in 6x instead. So I've got 2 times 6x plus 3 divided by 6x squared minus 2 times 6x plus 1. And we're going to simplify that. I'll talk about 2 times 6x. That would be 12x plus 3. On bottom, I've got 6 squared is 36. X squared is x squared. And then negative 2 times 6 would be minus 12x. And then plus 1. And 4c, this is where we get into start looking a little bit more like calculus. We're going to plug in negative 3a plus 8. Being able to do this will be very important, whether you're taking A, B, or BC next year. All right, everywhere I see x, I'm going to put in negative 3a plus 8. So I've got 2, not times x, but times negative 3a plus 8, and then plus 3. And my denominator up there, first I've got x squared, so that's going to be negative 3a plus 8 squared. And I got minus 2x, so negative 2 times negative 3a plus 8. And then plus 1. That's a little bit gnarly. We're going to simplify that down a little bit. So 2 times negative 3a would be negative 6a. 2 times 8 is 16, plus 3. On the bottom, we've got negative 3a plus 8 squared. So negative 3 times negative 3 would be 9a squared. And then I got negative 3 times 8 is negative 24a minus 24 would be negative 48a. And then 8 times 8 at the end would be plus 64. So all of that is just this guy multiplied out. Next we've got negative 2 times negative 3, that's plus 6a. Negative 2 times 8 would be minus 16, and then plus 1. Whew, a little bit of work there, huh? All right, let's see, oops. Let's get it to extend down a little bit more. On the top, all we could really do at this point is negative 6a would be by itself, and then 16 plus 3 would be 19. On the bottom, I've got 9a squared, nothing to add or subtract to that. And then I've got negative 48 plus 6a, that's going to be negative 42a. And then I've got 64 minus 16. Let's see, 64 minus 10 would be 54, minus 6 would be 48. And then plus 1, 48 plus 1 would be 49. And then that would be our answer. Everything's simplified as far as we can take it. So that's evaluating a function. And our next video is going to be on finding the domain of a function.